Hello, assalamu alaikum. Very excited to be starting day 3. This is the last day that we're going through the very basics of the quantitative section, and we're going to the core GAT material starting tomorrow. What are we going to be doing for today? Divisibility, factors, and multiples, a very basic arithmetic concept that's required all through mathematics forever. The next thing we'll be looking into is the table of 4. I hope you've gone through it a few times, starting from 4 times 1 to 4 times 20. Just keep the times table in front of you, go browse through it over and over again, and the numbers will start absorbing in before you realize. 5 new words go into our workout journal. I've brought you 3, and I hope you've got the other 2 ready for yourself. Let's start with the first agenda. We're checking the divisibility. We're looking into the divisibility test 2, 3, 4, 5, 6, 9, 10, 11. How do we check if a number is divisible by 4? About 2. How do we check if a number is divisible by 2? Anything that's going to end up in a 0, 2, 4, 6, 8 is divisible by 2. So this number is ending up in an odd number, 7. It's not divisible by 2. This number over here is ending up in an 8. It is divisible by 2. This number over here is the third number is ending up in 0, which is an even number again, or the numbers that I require over here, to check the divisibility of 2, so that 2 is divisible in 2. The next number, number 4, is ending up in a 5, an odd number, right? It's not divisible by 2. The next number is, again, the last number is ending up in a 0, so it is divisible by 2. Very easy peasy. The divisibility test of 2 is extremely easy. I'm sure you're quite aware of it already. Now, how do we check the divisibility of 3? Well, you might know of this already. I'll go through it, review it with you. What we do is we add up all numbers. We add up all the digits in the number. That gives us 9 and 5, 14, 14, 7, 21. So when I sum them up, I get 21. That's the sum when I add up 9, 5, and 7. Well, the divisibility test of 3 is that when you add up all the integers, the number that you get, 21, is that a multiple of 3 or not? Is 21 divisible by 3 or not? Yes, it is, which is why we would say this number is divisible by 3. Let's take a look at the next number. Again, the same procedure. 2 plus 7 plus 9 plus 9 plus 5 plus 8. Oh, plus 8 plus 8. That's 16, that's 18. Let's say that with that together is 14. So now I'm adding up 14, 16, and 18. That gives me a 30, 48. So the total that I get by adding up all the integers, all the digits of the second number is 48. Is 48 a multiple of 3? Is 48 divisible by 3? If you know the table, we've done the table of 3 yesterday, if you know it from there, you would know, yes, it is divisible in 3. If not, let's add the digits again. 4 and 8, let's add them up. 4 and 8 is a 12. Is 12 divisible by 3? Yes, it is, which is why this is divisible by 3. I think I'm just going to highlight them. 2, 2, 2, 3, 3. Let's take a look at the next number. 5, 6, 7. Let's add them up. 5 and 6 and 7. Let's add them up. How much do you get? 5 and 6 and 7, that's 18, right? 5 and 6 and 7 is 18. So is that divisible in 3? Yes, it is. It's divisible in 3. Let's go to the next number. 1 plus 0 plus 0 plus 7 plus 6 plus 5. It adds up to give me 8, 6, 8, and 6, 14, 14, and 5, 19. When I add them all up, I get a 19. Is 19 a multiple of 3? No, doesn't look like, right? 19 is not a multiple of 3. We would just let that go. It's not a multiple of 3. Next number, 1 plus 6 plus 5 plus 0. That's 12. Is 12 a multiple of 3? Yes, it is. So we worked out the multiples of 3 as well. Even if you knew it, it's good to review. Next, divisibility of 4. Divisibility of 4. What we do with divisibility of 4 is that we check the last 2 digits. For example, 57 over here. Is that 57? Now, we've learned the table of 4 for today. If you don't remember them by heart, what you could do is keep the times table in front of you. 57. Does it come up in the table of 4? No, it doesn't, which means 4 is not a factor of the first number. Let's take a look at the second number, 88. 88. Is that divisible by 4? Is 4 a factor of 88? Now, we do know that 4 times 20 is an 80. 4 times 20 is an 80, which means 4 times 21 will be an 84. 4 times 22 will be an 88. So that gives us 88, which means, yes, it is a factor of 4. Take a look at the next number. The last 2 digits are 70. Number 3, the last 2 digits are 70. Never seen that in the table of 4. Let's cross that out. Next, 65. Next number, 65. Does that come up in the table of 4? No, never seen that. So it does not. 4 is not a factor of the fourth number. Let's take a look at the last number over here, 1650. 50. Last 2 digits, 50. Is 50, have you ever seen 50 in the table of 4? Nope, haven't. So the only number of which the 4 is a factor is the second one over here. Now, next we go and check the divisibility of 5. We go and check the divisibility of 5. I'm sure you know of this already. Any number ending up in 0 or 5. Any number ending up in 0 or 5 is a multiple of 5. So the first one, no, it isn't. The second one, no, it isn't. The third number is ending up in a 0. So yes, it is. 5 is a multiple. 5 is a factor of the third number. The fourth number, again, ending up in a 5, which means, yes, 5 is a factor again. 5 is a factor. The last number is ending up in a 0 again. So yes, 5 is a factor. So 5 is a factor to 3 numbers that we worked out over here. Next, we go to the divisibility check for digit 6. So we want to check which numbers are divisible in 6 completely, leaving us with no remainder at all. The first, divisibility check of 6 is such that if it's divisible in 2 and it's divisible in 3, here, let me write it down somewhere. So it has to be this one, has to be divisible by 2 and has to be divisible by 3. If it's divisible in both of them, that means yes, it is divisible by 6 too. So the first one is only divisible by the first number is only divisible by 3. That means no, the first number is not the 6 is not a factor of the first number. Number 2, 2 and 3. So yes, 6 is a factor of the second number. Number 3, 2 and 3 are both factors, which means yes, 6 is also a factor for this number over here, 6570. Next, 2 and 3, none of them are a factor for this number, so we're just going to skip that. Last, 1650, 2 is a factor, and 3 is a factor, which means yes, 6 is also going to be a factor. It's as easy as that. Let's take a look at the next one, number 9. Number 9. For number 9, the rule that applies is the exact same thing. We need to check if the sum, remember we worked out the sum, 9 and 5 and 7 give us a 21. We need to check if the sum is divisible by 9. If 9 is a factor of 21. Nope, never seen that in the table of 9, so it isn't. The next one, we added up everything and we ended up getting a 48. Is 48 in the table of 9? Nope, haven't seen that ever. Next, 5 and 6 and 7 give me an 18. Seen that in the table of 9? Yes, 9 times 2 is 18, so yes, 9 is a factor. Next, 19. We summed it all up and we got a 19. Never seen 19 in the table of 9, so 19 is not a multiple of 9. 9 is not a factor of 19. Next, we summed these up, 1650, and we got a 12. Ever seen 12 in the table of 9? Nope, 9 is not a factor. That's that. Next, we go to working out if the divisibility check for 10. I'm sure we know that already. Anything that ends up in a 0 is divisible by 10. 957 did not end up in a 0, so it's not divisible by 10. Next number, 2799, it does not end up in a 0, so it's not divisible by 10. Next number ends up in a 0, it is divisible by 10. Number 3, 5670 is divisible by 10. Next, 100765 does not end up in a 0, it's not divisible by 10. The last number ends up in a 0, it is divisible by 10. Done. Last, we've got how to check the divisibility of 11. Now, if you know this already, that's well and good. If you don't know it, just pay slight attention. We're going to be working out the divisibility check for 11. I'll do that over here next to the numbers. Let's go. Now, how do we check the divisibility for 11? What we do is we take the first number, 9, subtract the second number, add the third number. So basically what we're doing is odd numbers are plus, even numbers are negative throughout. Then we work out how much does it add up to. 9 take away 5 gives me a 4. 4 plus 7 gives me an 11. The resulting number, is this a multiple of 11? Yes, it is. 11 times 1 gives me 11. I think I should work with a different color. Let's work with purple. So 11 times 1 is 11. So yes, this number is divisible by 11. Let's go to the next one. 2. So first number is positive. Then I subtract the second number. Then I add the third number. Then I subtract the fourth number. Then I add the fifth number. Then I subtract the next number. And I add the last number. So plus minus, plus minus, plus minus. That's how it goes. How much do we end up getting? The 9 and the 9 cancel out. One's positive, the other's negative. 8 and 8 cancel out. One's positive, the other's negative. Now I've got 2. Take away 7. That gives me a negative 5. And I have to add the 5 into it. So it's negative 5 plus 5, which gives me a 0. Is 0 a multiple of 11? Yes, it is, because 11 times 0 gives me a 0. So yes, the second number is a multiple of 11. Excuse me. The second number is a multiple of 11, and you can divide the second number to work out. Divided by 11, you'll be left with no remainder. Let's try number 3. Positive, negative, positive, negative. How much? 5 take away 6, negative 1, plus 7, minus 0 is just that, negative 6. Oops, negative 6 is not a multiple of 11. So negative 6 is not a multiple of 11, which means 5670 is not a multiple of 11. Next, 1 minus 0 plus 0 minus 7 plus 6 minus 5. Oops. Minus 5. Let's work them out. Negative 0, haven't got anything to do with that. 1 minus 7 gives me a negative 6, then I'm adding in the 6. 6 minus 5. 6 and 6 cancel out. I'm left with a negative 5, which is no way it's not a multiple of 11. That goes off. Next. Positive, negative, positive, negative. 1 minus 6, negative 5. Plus 5 minus 0 is just 0. Negative 5 plus 5 is a 0. Wow. So that means 11 times 0 gives me a 0, which means 1650 is a multiple of 11. That's how we do the divisibility check. Looks a bit messy, no problem. If there's anything at all that you got stuck at, go back, review a few things, and then we will go forward to our first practice, which is a practice on divisibility. I'd very much like if you could give the answer before I do. That would be very nice. So we've got this in your worksheet, practice 1. We're working with divisibility. We're working with divisibility. Practice 1. Question number 1. 980138. Is it divisible by 3 or not? That's what the question is. How do we do divisibility check for 3? Add them all up. 9, 8, 0, 1, 3, 8. How much is that? 17, 18, 19, 20, 21, and 8 more, that's 29. Is 29 divisible in 3? Nope, it isn't, so no. This is not divisible by 3. Next question. Is 23925 divisible by 5? Very easy, straightforward answer. I don't have to work it out at all. Is it? Yes, it is, because it's ending up in a 5. So anything that ends up in a 5 or 0 is divisible by 5. Next. Is this number over here, 175903, divisible by 2? Oh, very easy answer again, because anything that ends up in an even number is divisible by 2. And 3 is not an even number, so no, it's not divisible. Next question, 182480. Is it divisible by 4? Remember the divisibility check for 4? We need to check the last 2 digits, which is 80 in our case. Is 80 divisible by 4? Yes, that's right. We just did the table of 4 today. 4 times 20 is 80. So yes, it is. Yes, it is divisible. Next question, 788047. Is it divisible by 4? So we're looking into the last 2 digits, 47. Now let me take a look. I do know the table of 40, and I know 40 times 10. 4 times 10 is a 40. So that means times 11 is 44, times 12 is 48. 47 is nowhere there. So nope. That's not correct. It's not divisible by 4. Next question. Hint, hint, hint. What's the answer? Yes it is, because anything that ends up in an even number is divisible by 2. Last, we're doing a divisibility check by 6. Remember what that was? A number has to be divisible by 2 and 3. So 2 and 3. Let's check that. 2 and 3. The last digit's 8, which means yes, it is divisible in 2. How do we do divisibility check for 3? Go on. 1, 2, 5, 6, 8, 8. 16, 11, 3, 14, 16, that's it, 30. Divisible in 3? Yes, it is, most certainly. So yes, it is divisible in 3. I hope you got the divisibility. I hope you roughly got an idea of the divisibility. It would require some practice, and no one's going to come up and ask you, is this number divisible by 11? But when the numbers do come up, it's very important to know what number is it divisible by, so you can simplify very huge numbers, like in practice 1, into very simple looking numbers and work with them very easily, even if you don't have a calculator, like we have to in GAD. Oh, what we've got next? Table check. In your worksheet, we've got the table check. Try and fill that in. Put your video to mute so you can check the answers alongside you're doing them. I'm sure you can do them, manage them on your own. Let's go. 2 times how much? We know the table of 2, so we need to split the numbers into factors. 2 times what gives me 36. It comes in the table of, correct, 18. Is it divisible in 3? Yes, that's the table of 12 as well. 3 times 12. 4, yes, we know 4 times 9 is 36. Next, 60. Split 60 into 2. 2 times, I know we've only done up until 2 times 20, right? But the idea of checking the divisibility of anything is why 60, I want to split them into 2. So that's 30 and 30. Not very difficult to go by, right? So let's try them. 60 divided by 2, 30. 60 divided by 3, 20. 4 times how much gives me 60? 15. 2, 24. Does it come up in the table of 2? Yes, it does. 2 times 12. Does it come up in the table of 3? 3 times 8. Table of 4, yes, I'm sure all of us know this. 4 times 6. 48. 2 times how much again? We're splitting 48 into 2. So I will just halve it. I can see that the half of 8 is 4, and the half of 4 is 2. 24, 24 each. So that's how we will be splitting when table of 2 comes up beyond 20. 24. 3 times how much? We've seen it in the table of 3 as well, right? 3 times 16, correct. 4 times, we've seen that. Table of 12, if you know the table of 12, you know this too. 56. Let's split that again. What I would do in my mind is 56. First of all, I would split it into 50 and 6. Then I would split the 50 into 25 and 25. And the 6 into 3 and 3. So we're looking at this, or we're looking at this. It's split into 2, 28. 25 and 3 is 28, and 28. That's how we do divisibility if the table of 2 comes up beyond 2 times 20. So we work that out. It's a 26. 3, table of 3. Haven't seen that in the table of 3. But yes, I have seen that in the table of 4, 14. 2, again, I'm going to split it. What I would do is 76. I would split it into 60 and 16. That's adding together. Then I know that's 30 and 30. And 16 split into 2 is 8 and 8. So it's 38 or 38. So that's the table of 2, 38. Table of 3. Table of 3. Does it come up in the table of 3? I'm not so sure. What should I do? Let me try adding them up. 7 and 6 is a 13. Does that come up in the table of 3? Nope. So I'll just rule that out. Table of 4. 76. Yes, I do know 4 times 20 is 6. 4 times 20 is 80. So it's 1 short of that. 4 numbers short, which means it's 4 times 19. Table of 2 again. So I would split it into 50 and 2. 50 split into 2 is 25. 1 more, that's 26. If you think this is, you can only memorize up until 20, any table times 20, no problem. Just skip the numbers that, if you're finding it overwhelming, no problem. You can skip the numbers that are going beyond 20. It's not, I don't mind, it's okay. Then we've got 52. 5 plus 2. 5 plus 2 is a 7. It's not divisible in 3. I'm checking the table of 4. Yes, I have seen it in the table of 4. 4 times 13. Give me a 52. Table of 2. Yes, 15. Very easy. 10. And no, it does not come up in the table of 4. 16. Again, very easy. 2 times 8. No, it does not come up in the table of 3. 4 times. 4. 2. Again, I would split 42 into 2. That would give me 21 each. Table of 3. I have seen it in the table of 3. 3 times 14. Keep the times table in front of you if you haven't internalized the numbers yet. It's not a problem at all. The main idea is you keep going through them over and over again. Keep the timetable in front of you. Take help from there and work them out. 2 times 9 is 18. 3 times 6 is 18. And no, it does not go in the table of 4. 2 times, again, I'm splitting this into 23 and 23. 3 times 4 and 6 together is a 10. No. That doesn't go in the table of 3. Table of 4, no, I haven't seen that in the table of 4 either. That's it, we're done with the table check. Keep practicing, review table of 2, 3, and 4. We'll be going into 5 and 6 and 7 later on, so it's going to get tougher and tougher. Actually, more challenging. Let's use nice words. It's going to get more challenging by the day, so be consistent with your timetables. Let's go to practice 2, where we get to practice a few of the skills we learned over here. One thing I want to highlight is the concept of factors. Oh, maybe you know of this already. I'm sure you know of them already, just reviewing. We're looking into factors, and we're looking into multiples. Now, if I look at, for example, I would look at 48. Then I would say 2, 24, 3, 16, 4, 12 are factors of 48, because 48 can be broken down into smaller numbers, smaller factors. So I would say they are all 2, 24, 3, 16, 4, 12 are all factors of 48. But when I look at the multiples, what would I say? When I look at the multiple, I would say 48 is a multiple of 2, is a multiple of 3, is a multiple of 4. Because 2 times something gives me a 48. 2 times 24 gives me a 48. 3 times something gives me a 48. 4 times something gives me a 48. Which means 2, 3, and 4. 2, 3, and 4. 48 is a multiple of 2. 48 is a multiple of 3. 48 is a multiple of 4. Just to get familiar and review the terms factors and multiples, because that's what we're dealing with now on. Let's go to practice 1. Let's go to practice 1. In practice 1, what we're looking into are factors. Let's take a look at question number 1. Which of the following numbers is a factor of 49? What they're expecting you to say is something times something is 49. What is that something? It does not come up in the table of 2. It does not come up in the table of 4. It does come up in the table of 7, right? 7 squared is 49. Does it come up in the table of 9? No, it doesn't. So 7 is a factor of 49. That's the idea. Let's try and do the other two before I do them. Which of the following numbers is a factor of 975? Let's take a look at the options. 2. Is 2 divisible in anything that ends up in a 7? Nope. If 2 is not a factor, can 6 be a factor? Because remember, 2 and 3 both should be factors for 6 to be a factor, so no, it cannot be a factor. Table of 9. Let's take the table of 9. I was supposed to add all digits and check if the sum is a multiple of 9. 9 and 5, 14, 14 and 7, 21. Is 21 divisible by 9? Nope. 11. What was the rule for 11? Plus, minus. Plus, minus, plus. Oops. Plus. So the first number is positive, the second number is negative, the third number is positive. 9 take away 5 is a 4. 4 and 7 is an 11. And 11 is a multiple of 11, because 11 times 1 gives you 11. So that's the answer. D. Let's take a look at the last question for this practice. Okay, we're looking at the next one. Which of the following numbers is not a factor? Which of the following numbers is not a factor of 10520? 2. Is it a factor? It's ending up in a 0. Is 2 a factor? Yes, it is. Next, I'm checking the divisibility of 3. 1, 0, 5, 2, 0. 5 and 2, 7, 7 and 1, 8. Is 8 divisible in 3? Nope. The last digit's ending up in 0 again, so that is divisible in 5. It's ending up in 0, that is divisible in 10. So 3 is not a factor of this number over here. Now that we're okay with factors, let's take a look at multiples. Practice 3, fill it in your worksheets. Least common multiple. Factors is what a big number is broken down into. Multiples is basically just the table itself. Now what they're saying is what's the least common multiple of 6, 10, 15, and 10. The quickest way to work about these problems is to take the biggest number, write down its table, let's say 15, 30, 45, 60, 75. You might not know the table of 15 as yet, but no problem, as we move on you would know it. So you can take help from the times table again. Now I've worked out I've worked out 15 already. Now I can list down the multiples of 10. 10, 20, 30, 40, 50, so on. Table of 6, 6, 12, 18, 24, because I know that the, hold on, my bad. 24, 30, 36, so on. What's common over here? They want exactly as what they're saying. They want the common. We've written down the multiples already. They want the multiple. They want the common multiple. As we can see, 30 is common in everything. 30 is common in everything. Very soon, by the way, very soon you would realize that we've also got a 60 here. After 50 comes a 60, right? And even in the table of 60, we do have a 60. So we've got 2 common multiples. Actually, we might have more, but so far we've got 2 common multiples. Because we're interested in the least only, we're going to pick 30. We're going to pick 30. So 30 is the least common multiple. But when you're working a question around this particular problem, all you can do is, the quickest way of going by is you take the biggest number, 15. Write down the table. I wrote down 15 and now I've constantly got 10 and 6 in the background. 10 and 6 in the background. Does 10 and 6, do 10 and 6 go in 15? No. Let's write down the next number. Do they go in 30? Write down the numbers. Do they go in 30? 6 and 10? Yes, they go in 30. Do they go in 45? No, 10 does not go in 45. 6 does not go in 45. 60? Yes, 10 times 6 is 60. So yes, it is. But this was the first one, so I picked 60. I picked 30. 30 is the answer. I picked 30. So the idea is that you just pick the big number, the biggest number, and write down the multiples, have the how many other numbers you have in the background, and you can then work their forth, which is what I'm going to do in question number 2. Instead of working out everything from the beginning, what I'm going to do is take the biggest number, 20, write down its multiples, 2 times 1, 20, 2 times 2, 40, 2 times 2, 3, 60, 20 times 1, 20, 20 times 2, 40, 20 times 3, 60, 20 times 4, 80, and so on. Now, I've got 4 and 12 in the background. 4 and 12. And I'm checking, does 20 go in 4? Yes, it does. Does it go in 12? No, it doesn't. Does 40 go in 4? Yes, it does. Does it go in 12? No, it doesn't. Does 60 go in 4? Yes, it does. Does it go in 12? Yes, it does. So that's my answer. Do you see how quicker this workout was as compared to that one there? So all we're going to do is pick the biggest number, write down the multiples, and then double check with the other 2 numbers. That's that. That's it. Shall we go to the next topic? Next exercise, we've got vocab building coming up. I hope here I've gotten you 3 words. I hope you got the other 2. If not, no problem. Go through any material, pause the video, go through any material on the internet, newspapers, articles, anything. Let's fill in the other 2 numbers as well. Let's go. So 3 words. Let's start with the 10. You've heard that before. I'm so sure you've heard that before. What does it mean? Something to do with courts, right? Attorney is a lawyer, basically. So we can say, I'm not going to write it up, you could. So I could say attorneys, which is lawyers. Attorneys, they sue people, they defend people, and serve as experts on law. So attorney, our first word for today, means lawyers. Lawyers are what you hire when you have to fight a case in the court. Next word for today is apt. Apt is when you are inclined to a direction, to a side or a direction. When you have a tendency to do something, so you're apt to do that particular thing. And which is why you could be very quick to learn that thing because you have it in yourself, so you only need a very small exposure to it. It also could imply in saying something very, very appropriate or very suitable. So do you see how, although they sound like 3 different meanings, but they're almost one and the same thing? So something that's suitable. So something that is suitable. Or something that, a tendency to do something, let's say. Tendency to do something. Let's say, what sentence can I make? With his dark, brooding persona, actor Christian Bale is an apt Batman. So he's inclined towards it. He has a potential to be that. That's what it means, apt. The third word for today, aquifer. The third word for today, aquifer, is basically a layer of rock and salt underground. A layer of rock and salt rock and soil underground. Did I say salt? Rock and soil underground. That's what an aquifer is. So, for example, when we dig a well into the ground and we pull out the water, it's because the aquifer is holding it. So the aquifer, layer of rock and salt. Layer of rock and, why am I saying salt again and again? Sand. Layer of rock and sand. So there's a layer of rock and sand that basically holds water on top of it. It doesn't let it go through, which is why when we dig down into the earth, we can take out the water, because it's not like there's an ocean down there. It's because there's a rock of soil, and there's a layer of rock and sand that doesn't allow the water to seep through. So that's an aquifer. For example, I could say our town gets its water from the underground aquifer. Our town gets its water from the underground aquifer. They have underground water system in like the remote areas. Okay, that's it. Fill in your other two words and work out the meanings. We're done with our vocabulary. Attorney means a lawyer. Apt means something you have a tendency towards, or something that's very suitable or appropriate. Aquifer is a layer of rock and sand underground that holds water. Let's go to the next exercise then. Once you're done with filling in words 4 and 5, let's go to the guided practice. Okay, for our guided practice today, we've only got 6 questions because they're not going to be very much GAT style, although there's divisibility questions like 1, 2, 3 have come up, but we're going to go into the core GAT material after today, tomorrow onwards. This is just as long as we understand divisibility, factors, multiples, get them on our fingertips, very easy gliding through them. That's it. That's the aim of today's lesson. So let's take a look at the first question. I'd like you to give it a try before you go through my explanation. Let's go. If a positive integer n is divided by 5, so n is divided by 5, I get something plus a leftover of 3, right? So a positive integer n is divided by 5 and the remainder is 3. Which of the following numbers below yields a remainder of 0? So which of the following numbers below yields a remainder of 0 when it is divided by 5? The easiest way to go by questions like these is now trying to work out the value of n. What would n be that I get a remainder of 3? I know, for example, I'll choose the very, very basic number. 5 divided by 5 would give me a 1. If I increase that 5 3 numbers, because my remainder is 3, if I increase it 3 numbers, which means add 3 into it and make it 3 plus 5 plus 3 and 8, and then I divide it into 5, what would happen? 8 chocolates divided into 5 girls, each would get 5, and I would have 3 left over, right? So do you see what I did over there? I know 5 is a multiple of 5, so I just used that. So 5 divided by 5 would give me a 1. I said, okay, because I have a remainder of 3, what I would do is add 3 into a multiple of 5, get 8, and work it out. I can do it with anything at all. Even if you want to choose, for example, 5 times 2, 10. 10 divided by 5 is a 2, and there is no remainder. Remainder is 0. Add 3 into it, you get 13. When 13 chocolates are divided into 5 girls, each girl gets 2, and your remainder is 3. That would work out with all the multiples of 5. 5, 10, 15, 20, etc. But because I want my work to be very easy, I'm going to pick the simplest possible, which is just a 5. Now that's done. Let's start with these things as well. Now that's done, so the number that I came up with is an 8. 8. Right? The number that I came up with is an 8. Now what they're saying is, which of the following numbers below yields a remainder of 0? No problem, I'll just substitute 8 in place of n. 8 plus 3, 11. 8 plus 2, 10. 8 minus 1. 8 minus 1 is 7. And 8 minus 2 is 6. They were saying, where would you yield a remainder of 0? So when divided by 5. 11 divided by 5, no, the remainder is not 0, we do have leftovers. 10 divided by 5, 2 exactly, and there is no leftover at all. So that's my answer, part B. Let's go to the next question. When the integer n is divided by 8, the remainder is 3. Just like the previous question, so n is divided by 8. And I'm left over with something plus I have a 3. What do you think is that number? Now, I know I'll do the exact same thing. I'll pick any multiple of 8. In the previous question, it was a 5, right? In the previous question, it was a 5. In the new question, in the next question, it's an 8. So all I'll do is, I was working with multiples of 5 in the previous question. I would work with multiples of 8 in the next question. 8, 16, 24, so on, anything. Choose any number, it doesn't matter because I want my workout to be very easy. I'll use the very small number. Now, I know 8 divided by 8 gives me 1, and the remainder is 0. But I want a remainder of 3, which means I would add a 3. 8 plus 3 is an 11. 11 divided by 8 would give me, everyone gets 1. 11 chocolates divided into 8 people. Everyone gets 1, and the remainder, the leftover, is 3. So 11 is my number. The integer n is 11. It's divided by 8. The remainder is 3. Done. I worked out the number 8. Now let's go to the next part of the question. What's the remainder of 6n? 6n, now I know n is 11, so I would say 6 times 11, 66, is divided by 8. What happens when 66 is divided by 8? Now, I do know that 8 times 8, I'm picking the closest multiple of 8, close to 64. So 8 times 8 is 64. I know that if there was a 64 divided into 8, everyone would get an 8, and there would be no left over, right? But because these are two items, let's say chocolates, more than 64, I would have a 2 left over. 2 would be the remainder. So it would go 8 times, and I would be left with a remainder of 2. It would go in this 8 times exactly, and I would be left with a remainder of 2. I hope that's clear. If not, go through it one more time, rewind the video, and go through it one more time. Inshallah, it's easy. So that's my answer. C, the remainder is 2. Next question. If n is an integer, when 2n plus 2, the entire thing squared, is divided by 4, the remainder is what? Now, n is an integer, and we don't know what the remainder is. What we can do is, I have 2 options. Either I could pick a few numbers, let's say 1, 3, 1 and 3. So I would say 2 times 1, 2, plus 2, squared, that gives me 4 squared, 16. 3, 2 times 3, 6, and 2 squared, that's 8 squared, 64. They're asking, so I just choose and if you choose a few numbers, put them in place of n, and check when it's divisible, if it's divided by 4, what's the remainder? That's the question, right? So 16 divided by 4 is a 4, there's no remainder. 64 divided by 4 is a 16. Table of 4, we did it today. Is a 16. divided by 4 is a 16. So there is no remainder at all, which gives me this as the answer. If you would like to go through it, in another way, I would say do what? Open up the brackets. 2n plus 2, it's squared. This is a square up here. It's squared, which means I write it 2 times. When I open up the brackets, we'll be doing the opening up the brackets in detail when we reach algebra. I'm going to get 4n squared plus 8n plus 4. Do you see that this is a multiple of 4, this is a multiple of 4, this is a multiple of 4. 4 times 1, 4 times 2, and whatever the n comes up. 4 times 1, whatever the n comes up. Do you see everything is a multiple of 4? When things are a multiple, when any number is a multiple of 4, which means we would not have any remainder. It would divide into 4 completely, which is why 0 is the answer. So you can do it either substitution method, trial and error, or you can do it opening up the brackets, sort of, let's say, theoretical way of doing it. Done. Let's go to question number 4. What is the smallest integer that is a multiple of 5, 7, and 20? Easy peasy, because the options are given. 5 is a multiple, 7 is a multiple, 20 is not, for 70. 35, 5 is a multiple, 7 is a multiple, 20 is not. 5 is a multiple, 7 is not a multiple, and 20 is a multiple. 140, 5 is a multiple because it's ending up in a 0, 7 is a multiple because 7 times 2 is 14, and this is just an added 0, so it's 7 times 20. And 20 is a multiple as well, very clearly, because, okay, I hope you know what we're doing. 140, right? If I divide that by 7, 5 is straight away, because it ends up in a 0, it's divisible by 5, done. What I would do is ignore the 0 for a while. I would only do 14 times 7, 14 divided by 7, that gives me a 0, and then bring back, what am I saying? 14, again. 14 times 7 would give, 14 divided by 7 would give you a 2. We ignored the 0 initially, so we can bring it back, put it here. So yes, it is divisible by 7. Let's take a look at 20. Is it divisible in 20? The 0 and 0 cancel out. When it's division, 14 divided by 2, 7. So yeah, yes, it is divisible in 20. That's your answer, D. Next question. What is the smallest positive 2-digit whole number divisible by 3 such that the sum of its digits is 9? So we've got there are two things in the criteria of the number that we're looking at. It should be divisible by 3, and the sum should be 9. Let's take a look. The sum is 9. The sum is 9, the sum is not 9. The sum is 9, the sum is 9. So I'm looking at A, C, and D. It has to be divisible by 3. 27 is divisible by 3. 72, is it divisible in 3? How do we work that out? 7 plus 2. 7 plus 2, 9. So yes, it is divisible in 3. 8 plus 1, 9 again. So yes, it is divisible in 3, which means 27, 72, and 18 are all possible answers, but because they want the smallest positive 2-digit number, 18 is the smallest answer. Last question, question number 6. Which of these numbers is not divisible by 3? Very easy question. Let's work it out. You just got to add everything up and check if it's divisible by 3 or not. 3 and 3, 6, 6 and 9, 15. Yes, it is. Comes in the table of 3. Next, 3 plus 4, 7, 7 plus 2, 9. Yes, it does come up in the table of 3. 5 plus 5, 10, 10 plus 2, 12. It does come up in the table of 3. 1 plus 1 plus 1 plus 1, 4. Yes, it does come up. Oh, it does not come up in the table of 3. I'm quite absent-minded today, as you can see. Okay, glad that we're done with the lesson. So the 3 things that we were supposed to do today was go through divisibility, factors, and multiples. Done with that. Now, this is going to come in handy for the next lessons. Upcoming lesson, we're going to be starting fractions tomorrow, which is where we're going to be using fractions and decimals tomorrow and the day after tomorrow. So this will come in handy. The next thing we were supposed to do is the table of 4 all the way from 1 to 20. Hope we've internalized that as well. Go through it a few times. Don't procrastinate. 1 or 2 times daily would suffice, inshallah. Then last thing we were supposed to do was vocab, and we added 3 new words into our vocab journal. 3 new that I gave you, and hopefully you got the other 2 as well. Attorney, which meant lawyer. Apt, which meant something very suitable and appropriate. Aquifer, which was a layer of rock and sand underground that holds water. So we're done with that too. 3 things. The agenda for today is done. Let's adjourn our lesson. Keep using your vocabulary in every day, because it's going to get challenging next week onwards. So I'll see you tomorrow. Take care till then. Bye bye.